Today our topic is analysis of first order RC circuit. So here what will be the time domain analysis when RC is excited with the DC source. That means we are going to get transient and steady state currents. Okay, so when DC is applied for RC circuit, what will be the current? And we know that resistor will be at initial conditions and final conditions, resistor will be resistor itself, whereas coming to the capacitor, so if I consider the capacitor, the initial condition is because it depends upon the past history. So capacitor is a storage element, no? So it depends upon past history, so that it is initially at initial condition, it is a short circuit. Okay, voltage source and okay, it is a short circuit, it is. And whereas coming to the final condition, that means at t equal to 0, it is behaving like past history, that is about short circuit. When t approaches to infinite, when t approaches to infinite, it becomes open circuit. Okay, so based on this analysis, what will be the current, actual current flowing in the circuit? Okay, because it is depending upon the past history, so because let me find the current I by using this technique. So here it is a closed circuit is there. When switch is closed at t equal to 0, so we can apply KVL here. When you apply KVL, these two will be the passive elements which are going to drops. This is VR and VC, and this is the active element, that is the source. That is why sum of voltage sources, that is the potential rise, is equal to sum of potential drops. So potential rise I have indicated with V, and potential drops, that is VR and VC. V suffix R is I into R, according to Ohm's law. And VC, the capacitor voltage, is given by 1 by C integral I into dt. So this is the equation we got actually. Okay, now what I am doing is I'm differentiating on both sides. If I differentiating on both sides, what you will get, V is a constant voltage, no? So V becomes 0, so that is V is replaced by 0, and R here. And what about the current? The capacitor is a it depends upon past history and present, no? So that's why it is a differential one, so that's why R into di by dt plus 1 by C integral. If you do integration, what happens? Integration and differentiation will get cancelled, only the term will be there, that is I is there. Okay, this is the term actually I got, that is R into di by dt plus 1 by C into I. Now in order to make it into one standard equation, what I am doing is I am dividing with R on both sides. So if I divide with R on both sides, 0 by R is 0 itself, and R by R is value is 1 into di by dt is di by dt, and 1 by I by C is there, no? I by R is there, no? R will be multiplied in the denominator, that is I by RC. So this is the equation I got. So this equation, what I am doing is I am comparing with the standard equation, that is the homogeneous equation. That is homogeneous equation is dx by dt plus ax is equal to 0. For this, the solution is, x is equal to c1 e power of minus at. Okay, so based on that, I can compare with this equation. So what will be a here? If you compare a, that means here x is nothing but current only, and compare a from this, what is a is equal to, if it, here x is equal to current, x is current means a will be 1 by RC. So just substituting, that means solution you are going to get as x is replaced by I. Now C1 is a C1 itself because it is a constant, and e power of minus at, a value is 1 by RC is there, minus 1 by RC into t. So this is the actual value I got. So what about the value of C1? So in order to find a C1, you just apply the analysis which you know. Okay, so when t equal to 0, when t equal to 0 means this is the initial condition, no? When t equal to 0, what is the capacitor behavior? It is the depending upon past history. Let us that it is a short circuit. Okay, because it is a past history, that is a short circuit at t equal to 0. Short circuit means just capacitor is replaced by short circuit here. You will be having this circuit is going to have only one resistor. That is why when I apply KVL here, okay, I is equal to V by R, V is equal to IR, we are going to get I is equal to V by R. So that is the value of current we are getting here now. That means at initial conditions we got. This is the equation number 3. And this equation number 3 is going to substitute here in the equation number 2. What will be the equation here? So let us substitute that equation number 2. This is the equation number 1 we got. Okay, substituting this equation number 2, equation number 2, what you are going to get? You are going to get the value, value of C1. Okay, let me clear all these things first. Here you can observe that I is equal to what we got this one, no? I is equal to V by R. When you are substituting, I is replaced by V by R. C1 e power of minus 1 by RC into T. And what is T here? T is equal to 0 case. That is why T is replaced by 0. E power of 0 is what? 1. Okay. So which is nothing but this term is C1 only. C1 is equal to V by R. That means we are going to get the value of C1. So after getting that value, you just replace this equation because you got the C1 value, no? You just replace it. I is equal to C1 is replaced by V by R, e power of minus 1 by RC into T. This is the actual solution. And the response with respect to time, how it is the exponential term, and the exponential power, it is negative term. So which is nothing but exponentially decaying. So just now we saw that how the current capacitor final condition, just now we saw that capacitor final condition is open circuit, no? From short circuit to open circuit. Open circuit in the sense current is 0. That means current should approach to 0. Current is approaching to 0 only, no? How just now we saw that current is 0. How the current is 0? By using this value, if you substitute that values, it is slowly approaching to 0. That's why I have said that in the final condition the capacitor is behaving like open circuit. That is why this is the graph like this. Now we got resistor and capacitor, no? Let us see that responses also, how the graph will be there. So we just substituting the value of voltage drops, that is VR is equal to I into R, and we got I as V by R e power of minus 1 by RC into T, and into R is there, R is multiplied here, R gets cancelled. We will be having V into e power of minus 1 by RC into T. So which is also a exponential term. That means the graph will be decaying. Okay, with respect to time, it is decaying. This is V suffix R. And what about the capacitor? Let us go with the capacitor. Let me clear first all. So if I see for the capacitor voltage now, okay, if I see for the capacitor, what is capacitor? VC is equal to, this is VC ma, VC is equal to 1 by C integral IDT is the formula. And we got that I value, we got that V by R e power of minus 1 by RC into T is there, no? So here whatever the constants are there, you can keep it out. So it is V is there constant, R is there constant. I'm keeping out V by R constant, that is V by RC. Exponential term is there, exponential integration if you do, it is the same term you are going to get, e power of minus 1 by RC into T. And this exponent, the exponent term is there, no? If you do the integration, it will be 1 by of that one. 1 by of this reciprocal term will be in numerator, it will come, that is RC. And the exponent, if you remove that, you will be having some constant K. So this is the thing we got, RC, and here RC is there, this RC will get cancelled. So finally we will be having VC is equal to, this is VC value, VC is equal to how much you are getting, ma? VC is equal to, this minus is there, no? Because it is minus term is there, we got minus V into e power of minus 1 by RC plus T plus K. So we should find the value of K, no? In order to find that value of K, this is a constant. So what I am doing, I am again applying the initial conditions. We know just now we saw that initial conditions, capacitor is behaving like short circuit, no? These things, how short circuit, already explained in the previous lectures. You just see, you can watch that videos. T is equal to 0 and VC is equal to 0. So at T equal to 0, capacitor, that means capacitor is behaving like short circuit. Short circuit means voltage drop is 0. So that means I am substituting VC is 0, no? Just VC is replaced by 0 minus V into e power of minus 1 by RC, and T is equal to 0, no? Just to substitute T equal to 0 plus K. So when you substitute, e power of 0 is 1. Okay. E power of 0 is 1. 1 into V is minus V. So minus V, if I shift this side, it is plus V. That's why I got the value of k as plus v. So after getting this value of v, value of k, I can substitute in this equation. No? So when I substitute this k equal to v in this equation, what is vc? Vc is equal to k value is v plus v, and this minus term is there, no, minus v into e power of minus t by rc. So v is common here. It is approaching 1 minus, it is 1 minus e power of minus t by rc. Just now we discussed that e power of minus value is the decaying term, but 1 minus e power of minus 1 will be exponentially increasing term. Okay, let me clear first. Exponentially increasing term. Okay, so the graph will be like this, exponentially rising. So this is the exponentially rising, this is the capacitor voltage, and this is the, just now we saw no resistor, this is the drop vr, and this is the drop of vc. It will be exponentially increasing because 1 minus e power is there. Okay, so from this again we gotta get, that means actually it is approaching to unity, you know, dc voltage means approaching to unity. That means, so from this we can get the tau. That means when it is up, how it is approaching to unity, from this time constant will be there. Based upon the time constant, it is approaching to zero. So what is time constant? Time constant is defined as time at which the exponent of exponential term is becoming unity. Just now we said no, it is becoming unity. So here what is the exponent of exponential term? Exponent is t by rc only, no. So this is t by rc. So what is that? Is why I have written t by rc is equal to approaching to unity, no, is equal to 1. So t is equal to rc, which is called as tau. This is small t is replaced by tau. Okay, so after that means rc is replaced by tau. So I, in the final solution we got I as, no, that one I am replacing I as, I is equal to v by r e power of minus 1 by rc. Okay, minus 1 by rc into t is there, no. So this rc can be replaced by tau. So that is why, okay, this is t, small t is there, no, minus t by v by r e power of minus t by, okay, tau is there, no, minus t by tau. This is the equation I got. So just now we saw the graph, no, we will substitute. If you, it is approaching to, what is the current final condition? If you substitute e power of minus 1 means the graph is 0, no. So it is I is approaching to, 0 at final condition, 0 at final condition. So when you substituting t, when you substitute t equal to 0, let me show you. Just now I said no, t is equal to 0. So in that above equation, let me take pen. Here t is, okay, minus t by tau it is. This is minus t by, this is minus t by tau. When t equal to 0, e power of 0 is what? Okay, when t equal to 0. So when t equal to 0, what will be the current? Okay, what will be the current here? Okay, let us see that when e power t equal to 0, I is equal to, let me see, I is equal to v by r into e power of t is 0, no, 0 by value, e power 0 is 1, no, 1, that is v by r. So this value is not 0, it is v by r. When t equal to tau, tau is there, no. Now when t equal to tau, it is v by r e power of t is replaced by tau, nothing but tau by, sorry, tau by tau, e power of minus 1 is there. E power of minus 1 value is 0.368 approximately into v by r. See, you can see that value. The next, see here, when t equal to 2 tau, that means this is 2 tau by t is, the value will going to approaching to 0.135. You just observe that this is the maximum value we are having v by r. Slowly you can observe that the value is keep on decreasing. It is 1, it is 0.368, it is 0.135, it is 0.0498, it is 0.018, 0.00106, V by R. Slowly it is as the T value increases, that means as T is equal to 60, 70, it is almost approaching to 0. Exponentially decaying, no, the current is exponential decrease, that means it is approaching to 0. That means it is an open circuit in final condition. Okay, thank you for watching. Please subscribe and share. If any doubts are there, you can ask me through the mail or comment section. Thank you.